much exam type questions. We understand that actually in portfolio analysis, the crucial thing is finding the variance. So if you have, let us say, two assets, it's not an issue. You can always find the covariance. I and J represents, can you see that? Yeah, I and J represents two different assets, asset I and asset J. And if you have only one, let us say two assets, then it's not an issue. You can easily find the covariance, and then you can get the correlation coefficient by just using the historical data, and you can plug in these values in the formula for the variance of the portfolio. But we understand that it is not so easy. If you have, let us say, 1,000 assets, for example, it is very much possible when you are handling a huge sort of portfolios. If that is not 1,000, at least you would expect that actually hundreds of assets in your portfolio. Then you would end up with thousands of covariances you are supposed to estimate, which is very difficult, because we should also remember that it's not basically estimating the historical covariance. Historical covariance is basically a matter of collecting the data for two columns, and you just use Excel or whatever it may be, the software, and you get the covariance. Remember that actually for portfolio analysis, you are supposed to forecast the covariance. Hope you understand that. If you can plug in the forecast for the covariance, then actually you are in a position to understand the future variance or future risk of the portfolio that you are going to handle. Okay? Hope you understand this problem. And now we discussed that there is a shortcut. Instead of estimating thousands of covariances, we would like to follow a simple strategy, that is a sort of assumption. Let us say that you have, this is what in the last class, the last part of the class is about. You have asset I and you have asset J, and you are supposed to estimate the covariance between these two assets, which is obviously a tricky thing when you have thousands of assets. But what we have done is basically we assume there is a market, because every asset is a part of market. For example, if you are considering UK market, then FTSE 100 might be a sort of proxy to the market. And what we assume is, whatever it may be the relation these two assets have, that is through the market only. So that means they depend on market. They both depend on market, so that actually indirectly they are related to each other. That is the assumption when you are considering the models, single index models. This is what we were discussing. Do you have any questions at this stage? Hope you've gone through the textbook or the lecture notes. Any questions up to this point? So this is what actually we were planning, and we did a sort of we have two methods. We discussed about the Bloom's method. It's basically estimating the covariance. And before that, actually, we also derived the following interesting relationships. According to this graph, or this diagram, the returns from the ith asset is equivalent to, we have done the regression analysis, if you remember, Rm plus Ei. This is sort of simple regression. We assume that asset I is related to market M. That relation is captured by using the regression line. Okay? Nothing else. And as usual, Ei is the error. Due to the regression, we try to minimize the error. So that means the summation of the error is going to 0. That's why you would end up with expected value of Ei equals to 0 in case you have any doubts about it. but that is not very important from practical point of view. That's a sort of bit technical thing. What you should remember is basically the relation between asset I and market M can be expressed like this. Okay? And the expected value of asset I, that is expected returns from asset I, is going to be alpha I, beta I, expected returns from the market. That's the basically first relation we have verified. I don't see any problem in memorizing this. After all, it looks like a straight line. What you are doing is the expected returns from any asset is linearly depending on the expected returns from market. That makes sense, well, at least statistically. Okay? And the second relation that we observe is you can use the same sort of underlying assumption, that is basically asset I is related to market M through the regression analysis, and variance of asset I can be expressed as beta I squared sigma M squared plus sigma EI squared. This is the second relation we derived. That means once you know how to do the regression analysis for the returns of the asset and returns of the market, you can find the beta value. Okay? For each and every asset, there is a beta value. Okay? By knowing the beta value of the asset, you are in a position to estimate the variance of the asset. Okay? That is according to this relation. And the third one is, this is the most important thing, because we have an issue with sigma ij. It is very difficult to estimate the covariance. That's why we made this assumption. There is no special relationship between I and j. Whatever it may be the relationship they have, that is through the market. Okay? According to the assumption, we derived that this covariance between I and j is going to be beta I times beta j times sigma m whole squared. That means if you want to find the covariance between any two assets, what you need to do is do the regression between asset 1 and market, you get beta 1. Do the regression between asset 2 and market, you get beta 2. By using those betas, you can easily calculate the variance of the covariance of any given two assets. So this is a sort of simplified method. We bypass many complicated issues here by making a simple assumption like this. On many occasions, this assumption might be a sort of sensible thing, but there are some issues with this assumption, but we don't consider those kind of difficult situations with this assumption. We always believe that, at least while doing this course, that this assumption is valid. This assumption need not be valid all the time. Okay? Any questions here? Did you follow the story so far? Okay. So now, if you want to do the portfolio analysis, what you need is basically all possible covariances, and you know how to get the covariances by just using these three simple formulae. Of course, in fact, that is just by using the third formula. Sigma ij equals to beta of the first asset times beta of the second asset multiplied by the market variance. Market variance you can easily get from historical data, and you can easily find the covariance. Now, we have also discussed that there are some issues while estimating the beta values. If you remember the explanation that we had in the previous class, let us say that this represents today. Okay? You may consider this as period 1, period 2, and the other side is period 1. By using the historical data, you estimate the beta values. Okay. And if you want to forecast, let me call that as sort of beta I1, beta J1. That means actually the beta values that you estimated using the historical data in period 1. Okay? So we would like to do the portfolio analysis into the future. For that we need the future covariances. Okay? What I am doing is, at the moment I have only access to the historical data. By using the historical data, I am estimating beta values of individual assets. Then I use those beta values and estimate the covariance of the future by using this formula. But the genuine question is, what is the guarantee that the betas that we have estimated would be the same into the next period as well, which may not be the case. Then what we need is, we need a sort of mechanism that would estimate the forecast the future beta values of the individual assets. So for that actually we discussed about the Bloom's method. That is ridiculously simple. It basically says that you need to do the regression analysis. So according to the Bloom's method, after estimating the beta values in period 1, then you can estimate the beta of asset I into the period 2 is according to a simple regression equation. You do the regression analysis. In the previous exercise we have seen this problem, 0.677 beta I1. How do we get this? Of course, it involves actually calculating many beta values. You need historical data. It's a sort of enormous computing task which cannot be done in class manually or in the final exam. What you can anticipate is basically, if you are supposed to use Bloom's method in the final exam, they will let you know the actual relation between the period 1 betas and period 2 betas. By using that information, you can estimate the beta values into period 2. Once you know the beta values in period 2, by simply using this formula, you can find the future covariances of any given assets. Do you understand that statement? Any questions on this? Any questions? Okay. That's the Bloom's method. That's very easy, and we have seen, I think in the last few minutes, we have seen a simple example. But if you just go back to that again. So look at question number 4. They have given you the relation between period 1 betas and period 2 betas by just displaying this equation. What is this? Beta I t plus 1. If t is today, that means present period 1, t plus 1 is tomorrow or period 2. Okay? So ith assets beta in the second period is related to these ith assets beta in the first period according to this linear equation. And they also provide you the beta values of the asset in first period. So once you get that, you can easily plug in those values to the given equation and you get the future beta values. Once you get the future beta values, then you can play around with the simple formula that you have. Once you get the beta values, you can plug in those values and get the covariance. Okay. don't get scared actually, even though the answer is so simple, they talk about, they may give a sort of very big story. Okay, we are basically doing portfolio analysis, we have hundreds of assets, I and J, and the first period beta values are estimated, blah, 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 and the relation is understood like this regression analysis. Then you can comfortably forget about the story and just focus on the regression analysis by just simply substituting the values here, and you get the future of the second period's beta values. Okay? This from examination point of view. And I will come back to question number 3. I think I already mentioned that, well, for the sake of practice, you may do question number 1, but it is not that practical actually, manually doing those things in the final exam. You don't expect question number 1, question number 2 in the final exam. But actually that would give you a sort of idea about how one can estimate the regression relationship. That's a sort of good exercise, but you don't expect those kind of problems in the final exam. So you certainly expect problems like question number 4, question number 5, and question number 6 and 3. Okay, let us move on to question number 5, and then after discussing this Vasicek technique, you are in a position to answer the rest of the questions. Before that, look at the question number 5. Read this carefully. Can you see that? Yeah. They have 4 different securities, A, B, C, and D. Okay? And their alpha, beta, EI values are given to you. Can you find the mean return of each security? How many of you think that actually part A is difficult? Genuinely. This is the data. Read the first part of the question. The mean return of each security. Can you find? Mean return of the. Do you think this is something like you have already a formula? Ri bar equals to alpha I plus beta I Rn bar. Do you think it's difficult now? You just substitute the values. So you just recollect at least this simple relation, very easy to memorize. And do you think the second one is difficult? Variance, you have, once you have access to beta values and the alpha value, then you can easily find the, for example, sigma I square is equivalent to, if you just look at your previous slide, which can be written as beta I square, sigma market square, plus sigma EI square. Do you think it's difficult now, finding the variance? You have sigma EI, error variance, for each and every asset, 3 square, and sigma M square, they have already given 25, and beta I square for individual assets. If you are looking at the, let us say, if you are finding the variance of the first security, then beta value is 1.5 whole square. Sigma market square is 5 whole square, and error square variance, that is 3 square, and you get the variance of SSA. Easy. Any questions? And the last one, I think now you can anticipate what would be the solution is covariance of returns between each security. How many covariance you could imagine when you have 4 assets? there are 6 possible combinations. So let me look at sigma AB. That is the covariance between asset A and asset B. You already know that the relation is through the beta values that you have already estimated, which is beta A, beta B times sigma m squared. What is beta A? Is 1.5. Beta B, asset B's beta value 1.3. Sigma market, the sigma m whole square is 5 square, and you get the variance between A and B. You can repeat the same exercise for the rest of the 5 possible covariances. That's it. You identify the covariances for all the given assets by using the single index model. Okay. And it simplifies the complexity because you need not worry too much about the complex relationship between I and J. The only relationship I and J have is through the market. That assumption would simplify the things. Because of that assumption, you can write the covariance is nothing but the multiplication of the betas of those 2 individual securities multiplied by the variance of the market. Understand logically what we are doing? So please remember, this would be a sort of examination question, and if you have the habit of putting stars, important kind of things, go ahead and remember this, okay? So you don't expect any complicated problem. The problem might look like so big. Okay? I might give a set of this much question. That doesn't mean actually that it's so complicated. Just think carefully, and it's a matter of actually, the solution is a matter of 3 or 4 steps, nothing else. Likewise, like what we have done here. Okay? Any questions? So, you may expect a question on Bloom's method, and you may expect a question something like this. There is one more technique. Okay? If you understand the technique, then you are in a position to solve the rest of the problems. It might appear a bit complicated, but to be honest, that's very easy. Are you ready for the next simple technique? Any questions? The other technique is known as elastic method. Again, the story is very simple. You have 2 periods. Period 2, that means this is history, that is future, nothing else. And we estimated the beta values for the individual assets. We represent beta I1 is the estimated beta due to the regression between the returns of the asset I and the returns of the market. And you got the beta I1. Now the question is, what sort of modification is required in order to use the assets beta in period 2? And in Bloom's method, we assume a sort of linear relation between these 2 things. In Watsik method, it would give a little bit complicated formula. Even Well, I need a little bit practice action, otherwise I cannot memorize that formula. Let me write it down. So the future beta I2 is according to this one. Beta I, sigma beta I1 whole square So this is the formula. You need not lose your heart actually, but it's very easy to memorize. I will tell you, but you need a little bit practice at least. So, if you remember the Bloom's method, on the left hand side you have beta I2, on the right hand side you have beta I1. So basically you understand how beta I2 is going to depend on beta I1. Similarly, you have beta I2 and you are basically writing a relationship between beta I2 and beta I1. Okay? But the thing is, you are giving different weights. So, is nothing but average of all the assets beta values in the first period. Whenever you find bar, that means actually average or mean. So beta bar 1 means in your portfolio, let us say you have 100 assets. Okay? Each asset has its own beta. Okay? And average of those 100 betas you estimated in first period is beta bar 1. You need not do all these calculations. You should know the meaning of the individual terms. Every value will be given to you. Okay? You need not do any calculations here. So the average beta, and beta I1 is nothing but that particular asset's beta in the first period. And you have some weights. Any questions at this stage, up to this point? You don't get any sort of, I'm going to explain a bit more regarding these things, but that complexity won't arise in the final exam, but for the sake of understanding. Let us say that you have the first period and the second period, and you have 100 different assets, okay? 100 different assets are considered. So how many betas you have in the first period? If you have 100 different assets, how many beta values you could expect? 100, okay? So I'm just noting down the values of those individual assets beta values. The first asset's beta is 1.1. I'm just giving an example, okay? And second asset's beta is 2.1. Third asset is 4.72. And you have 100 different assets. The last one, 100th one, is minus 2.3. Okay? Do you think actually this is a difficult thing to digest? If you have 100 different assets, obviously each asset has its own beta value. Do you know how to find the average of those 100 assets? We all know that. The average of those assets I call as beta 1 bar. So I find the average of all those numbers and I call that as beta 1 bar. That means all the individual assets beta values average is this one. And this one is beta 1 of asset I. So one of the assets, let us say that this represents ith asset. In this case, this is sort of third one where I equals to 3. So 4.72 is my 3 1. Asset 3. Okay, that's the notation. So you have access to these values. And what are these sigma beta I1 squared? When you have you done regression analysis in any of the other courses? Regression analysis. When you are estimating the regression parameters, obviously you find some sort of variance, okay? Some sort of error in estimating the parameters. So this is what we call actually variance while estimating the ith assets beta, and this is basically the variance of these numbers. If I give a sequence of numbers, you know how to find the average. If you know how to find the variance of the sequence of these numbers, variance of the sequence of numbers, I call that as sigma square beta 1 bar. Okay. So that is basically what we mean by this formula. Or simply, you can say that this Waschek method is nothing but your estimating beta I2 is something like 0.8 beta 1 bar, 0.2 beta I1. I think now it is relatively easy to digest if I give this formula. Okay? What I am doing is I am giving 80% weightage to the average beta values and 20% weightage to the individual assets beta value. That is what exactly this formula is saying. If you look at this formula, this ratio will give you the corresponding weight for the average beta and the individual beta. Am I clear? Okay? So nothing else. This is also very simple, but only thing is you need a sort of complex formula. First time you may think that is very complicated, but once you understand this, I request you to remember this formula. That's a genuine request. Okay? Unfortunately, I was unable to give all the formula in the final exam. Actually, I'm leaking the questions. So, better remember the relation. Okay? Any questions at this point? So, once you know how to estimate the period 2 betas, then you can use those beta values and estimate the covariances. There ends the story. Let's see. So this is fourth one. Let us look at a simple problem based on this. Look at the third problem. Show that the Waschek technique leads to a simple proportional weighting of the market beta and the stocks beta. If the standard error of all betas is the same. So look at the formula. going to do the third one. Can you see that? Third problem, okay? So you need to recollect beta I2 equals to sigma beta I1 square, sigma beta bar 1 square, beta I1 square, beta 1 square, beta 1 square plus sigma beta I1 square times beta I1. Sorry? The first one is sigma, let me recollect. Beta I1 square, sigma beta I. Here, where is it? Sigma, second one or the first one? Is yeah, I think so. Yeah, you are right. That is sigma square beta I1. Yeah, you are right. Yeah, it's a bit tricky to memorize this, so as I said. Now, what is the question here? They are saying that standard error of all betas is the same. Standard error of all betas is the same. That means you have the variance in the, while estimating the average beta, and variance in estimating the individual beta values. They are assuming that all betas variance is same. That means what they are saying is indirectly beta I1 square is, let us say, some constant A. That is the same for all the S's. So then what happens? Beta I2 equals to sigma beta I1 square, sigma beta bar 1 square plus A, sigma beta 1 square, sigma beta bar 1 square plus A times beta I1. Oops. Okay. So basically, they are saying that the error in estimating the individual betas is same. So basically, variance of all the betas are constant. I assume that as a sort of constant, and it looks like that you have a sort of weight here and some other weight there. So now you can argue that this formula looks like a simple proportional weighting of the market beta. Weight 1, weight 2, and if you can add these two weights, actually you would get a sort of the total weight is equivalent to 1. So nothing else actually, this is the solution. You can't do anything. So it might look like actually a very complicated one, but when you plug in those errors, you could say that this looks like now actually a set of weights. Of course, you can substitute further. Beta I2 equals to, this is also A square by sigma beta 1 bar square plus A times beta 1 bar plus sigma beta 1 bar beta 1 square beta bar 1 square plus A beta I1. Okay. So do you think actually this would look like this? What is the sum of these two weights? When I add these two things, what I get? So that means actually you are giving some weightage to the average beta and the rest of the weight to the individual beta. Okay? So that is true if and only if the error or the variance of the individual betas, while estimating that actually individual variance of the betas is going to be constant. Let me explain this again. Read this carefully. I will come back to that in case if I was a bit hurried. Show that Wass-Crick technique leads to a simple proportional weighting of the market beta and the stocks beta. If the standard error of all the betas is the same, standard error of all the betas is nothing but sigma beta I1 square. For that we assume that a constant, this is the Wass-Crick technique formula for the second period's beta, and according to the given information I can assume that sigma square beta I1 is constant for all I values. I just write that as A. When I substitute A in the given formula, I end up with beta I2 is nothing but the first term times the average of all the betas plus another constant times the beta of the ith asset. And you know that the sum of these two weights is going to be 1 if you call this as your weight 1, this is weight 2, W1 plus W2 equals to 1. That means it looks like beta I2 is nothing but giving some weightage to the estimated individual betas, and the remaining weight you are basically assigning to the average of all the assets in your portfolio. That's it. You must be comfortable with this derivation, okay? Please try to practice. This is also an important thing to remember. And for the remaining problems, I think it's straightforward. You can easily find the portfolio beta, portfolios alpha for the given data. You use the same formula. And again, the seventh problem is using the Bloom's technique, and this is the relation. Calculate the second period's beta value from the previous data. Just plug in the values, you get the answer. 8 also very much similar, but the only thing is to do to Wass-Crick technique. Okay? Hope you can practice on your own. And it's very easy, okay? Don't lose your heart in case if you see a sort of very big explanation. As long as you are comfortable with the discussion that I made in the last 40 minutes, I don't see any issue. Okay? Practice. But before that, actually, try to understand the concept. Hope actually you are following the concept. And any questions? Any questions? Okay, let us take a few minutes break. And when you